Hi, I'm Patrick Reagan. Welcome to the Advanced Networking Concepts, Part 1, Enterprise Broadband Technology. During this video, we'll discuss the various technologies used in WAN connections, including cable and DSL lines, fiber connections, private lease lines, dedicated internet access, multi-protocol label switching, or MPLS, VPN over public internet, and generic routing encapsulation, or GRE. As always, stick around for the practice questions at the end to test your knowledge and help you prepare for the Network Plus exam. If you find this video helpful, don't forget to click the like button, and if you have not already, subscribe to the Pat Has Your Back channel for more tech training content and technical know-how. Enterprise organizations use various networking solutions to connect their sites together, often depending on the requirements for bandwidth, reliability, security, and cost. Enterprise organizations have access to a variety of broadband technologies designed to meet diverse needs in terms of speed, reliability, scalability, and cost. Traditional broadband technology include cable broadband, which uses coaxial cables to deliver internet, often alongside TV services with speeds up to 50 megabits per second to 1 gigabits per second and beyond in some areas with the DOC SOS 3.1 standard. It is affordable compared to fiber and widely available in urban and suburban areas. Shared bandwidth may lead to slower speeds during peak hours. Digital subscriber line, or DSL, transmits data over traditional copper telephone lines with speeds of 1 megabits per second to 100 megabits per second, depending on the DSL type. It's affordable and widely available. Symmetrical speeds possible with VDSL or SDSL. It has slower speeds and limited scalability compared to fiber or cable. Both are used in small to medium-sized enterprises with moderate bandwidth needs and availability in rural areas. Fiber optics broadband uses light signals transmitted through fiber optic cables for high-speed data transfers with speeds of 100 megabits per second to 10 gigabits per second or higher. Fiber optic broadband offers high reliability and speed. It offers low latency, suitable for VoIP over IP, video conferencing, and cloud computing. It's ideal for large enterprises, data centers, and organizations relying heavily on cloud computing. Ethernet over fiber. This Ethernet is delivered over fiber optics infrastructure with speeds of 10 megabits per second to 100 gigabits per second. It offers symmetrical speeds for uploads and downloads and high performance for local and wide area networks. Fixed wireless broadband connects to the internet via radio signals from a nearby tower with speeds of 10 megabits per second to 1 gigabits per second, depending on the provider and technology. It requires no physical cabling and offers quick deployment. It does require line-of-sight requirements, and performance can be affected by weather and distance. It can be used in remote or unreserved areas without fiber or cable infrastructure. Satellite broadband delivers internet through satellites in orbit with speeds of 10 megabits per second to 200 megabits per second and varies with providers like Starlink or HughesNet. It is available virtually anywhere and may be only broadband technology available for remote or rural locations. It has high latency due to the distance to satellites. Extreme weather can disrupt communications. Cellular broadband, such as 4G and 5G, uses mobile networks for broadband access. 4G LTE speeds are up to 100 megabits per second, while 5G speeds are up to 10 gigabits per second in ideal conditions. 5G offers low latency and high speeds. It offers high mobility and rapid deployment, but is dependent on cellular coverage. You may have data caps or higher costs for extensive use, and is often used in mobile offices, temporary sites, and backup connections. A private lease line is a dedicated communications channel that connects two or more locations for private use. It's a direct point-to-point data connections provided by a telecommunications carrier. The connection is exclusively used by an organization or customer who leases it, ensuring high security and reliability. It provides a constant and guaranteed data transmission rate, usually specified in the lease agreement. Unlike shared internet services, lease lines are always active and are not affected by traffic from other users. Symmetrical speed, which means upload and download speeds are the same, making it suitable for applications like VoIP, video conferencing, or large file transfers. Digital Signal Zero, or DS0, is the fundamental building block of digital telecommunication systems in the private lease lines such as T1 and T3. It represents a single digital channel that transmits data at the rate of 64 kilobits per second and supports a single full duplex uncompressed voice channel. DS0 is primarily used to carry a single uncompressed voice call or an equivalent amount of data using pulse code modulation, which is used to digitally represent an analog signal such as a single phone call. Common lease lines are T1, which has 24 DS0 channels, which was common in the United States and provides up to 1.544 megabits per second bandwidth. E1 has 32 DS0 channels, which was used in Europe and other parts of the world to provide up to 2.048 megabits per second bandwidth. T3 has 672 DS0 channels and offers higher bandwidth up to 45 megabits per second in the United States. E3 has 480 DS0 channels and offers 34 megabits in Europe and other regions. While T1, E1, and T3 and E3 lines were popular options in the 90s and 2000s, these lines are drastically declined over the years due to the rise of faster, more affordable, and flexible alternatives like fiber optic connections and Ethernet-based solutions. While it is secure and reliable, it's expensive and typically less scalable than newer IP-based solutions like MPLS and SD-WAN. Dedicated Internet Access, or DIA, refers to a type of Internet service where business is provided with a dedicated, uncontested connection to the Internet. Unlike shared broadband services, where bandwidth is divided among multiple users, DIA guarantees specific upload and download speeds exclusively for the subscribing organization. Key features include dedicated bandwidth, where the full bandwidth of the connection is reserved for the customer, ensuring consistent performance regardless of time or network traffic. Symmetrical speeds, where uploads and download speeds are equal, making it ideal for business applications like video conferencing, cloud computing, and large file transfers. Service level agreements, or SLAs, where DIA providers typically offer robust SLAs that guarantee uptime, latency, jitter, and packet loss performance. Scalability has bandwidth where it can be adjusted based on the organization's evolving needs, ranging from a few megabits per second to multiple gigabits per second. It offers high reliability with features like redundant paths, low latency, and robust support. DIA ensures minimum downtime and high performance. DIA is a premium internet service designed for business with critical connection needs. While it comes at a higher cost, the benefits of reliability, consistent performance, and scalability make it an essential choice for organizations that depend heavily on uninterrupted and high-quality internet access. Multiprotocol Label Switching, or MPLS, is a high-performance method for directing data across networks, commonly used in service provider and enterprise networks to enhance the efficiency, speed, and reliability of data transmission. It allows data packets to be forwarded based on labels with the shortest path rather than the long IP network addresses. It is a Layer 2 communication switching protocol that relies on compact switching labels to relay payloads to the next hop, as opposed to the Layer 3 IP addressing used in common IP routing protocols. This reduces the need for routing table lookups, as the packet forwarding decisions can be made independently on the network layer header. In theory, MPLS should provide quicker lookups and therefore lower latency. MPLS remains widely used in networking, particularly in enterprise and service provider environments. Although newer technologies like SD-WAN and Direct Internet Access, or DIA, are growing in popularity, MPLS still plays an essential role in networks where predictable performance, reliability, and security are priorities. MPLS circuits have been used to connect branch offices to each other to facilitate communications between the branches. For IP traffic destined to and from the public internet, the branch office is required to connect to the service provider core via Layer 2, as MPLS does not have Layer 3 routing ability. Once the packets are received at the service provider core, the MPLS labels are stripped and packets are dropped into the Layer 3 network to be routed to the public internet. MPLS may also be used in hybrid networks as organizations adopt cloud-first strategies. They may use their MPLS in a hybrid network model alongside SD-WAN, combining the benefits of both technologies for critical applications. When a packet enters an MPLS network, a short label is attached to it. This label contains information about the packet's path, which is determined based on criteria like quality of service or QoS, latency, and bandwidth. Routers within the MPLS network, known as label switch routers or LSRs, read the label instead of analyzing the IP header. Based on the label, they forward the packet to the next hop along the predefined path. At each hop, the router may replace or swap the label with a new one to direct the packet correctly through the MPLS path until it reaches its destination. The key components of MPLS are the label edge router, or LER, which is the provider router sits at the entry and exit points of an MPLS network where it adds or removes labels from the packet. Label switch router, or LSR, is the provider router within the MPLS network that makes forwarding decisions based on the labels. The benefits of MPLS are reduced latency, where labels streamline data forwarding, reducing the time routers spend analyzing IP headers. Scalability, where MPLS supports large, complex networks by simplifying routing decisions. Quality of service, or QoS, where MPLS can prioritize certain traffic, such as VoIP or video conferencing, ensuring critical applications have the required bandwidth. And reliability, where it supports fast rerouting around network failures, ensuring better availability. The disadvantages of MPLS is inability to route internet traffic locally. Since MPLS transport doesn't have a layer 3 routing capabilities, packets in and out of the branch offices need to go through the MPLS gateway, or LER, at the service provider core. This means any type of internet traffic will go through the expensive MPLS circuits just to connect to the internet. High cost of MPLS. MPLS transport is expensive, especially when compared to widely available broadband internet access lines such as DSL, cable, and fiber. The per bit cost of MPLS can unnecessarily consume a significant portion of the IT budget. Single point of failure. Although MPLS is often advertised by carriers as having higher uptime, it can still go down when the carrier experiences a technical problem. Since MPLS is primarily based on a single service provider and single transport, it can be crippled by a single point of failure. Limited bandwidth and long lead times. MPLS upgrades for higher bandwidth may not be possible in some cases or otherwise cost prohibitive. The lead times for MPLS installation and upgrades can be impractically long, hindering an organization's ability to scale and adapt to changing network environments. Virtual Private Network, or VPNs, are commonly used to connect enterprise networks across multiple locations securely and efficiently. This is typically done through a site-to-site VPNs, which create encrypted, virtualized tunnels between different networks, such as corporate offices, data centers, or cloud environments. A site-to-site VPN is designed to connect entire networks at different locations, such as branch offices to the headquarters or a data center. It establishes a permanent VPN tunnel between two or more sites, enabling seamless communications across the locations. The VPN creates a virtual tunnel that logically connects two networks while hiding the underlying physical networks from users. This allows multiple sites to communicate as if they were part of a single, unified network, even when they are physically distant. VPN gateways, which could be hardware or software, are deployed at each site to establish and maintain the VPN connections. These devices handle encryption, tunneling, and routing. VPN uses tunneling protocols to encapsulate and encrypt data. Data traveling over a VPN is encrypted to ensure security, even when transmitted over public networks like the internet. Common protocols include IPsec, or Internet Protocol Security, which provides encryption, authentication, and integrity for site-to-site tunnels. IPsec provides the most secure way VPN. Generic Routing Encapsulation, or GRA, encapsulates packets to create logical tunnels. Secure Socket Layer, Transport Layer Security, or SSL/TLS, often used for secure remote access VPNs, but can also support site-to-site connections. While VPN solutions are cost-effective and quick to deploy, they can have limited control over latency and performance, which relies on the internet connection. Managing multiple VPN tunnels across various sites can be challenging without centralized control or automation tools. While VPNs are scalable for smaller organizations, large enterprises may require more advanced solutions like SD-WAN, MPLS, or direct cloud interconnects such as Direct Internet Access or DIA for high performance and greater flexibility. Generic Routing Encapsulation, or GRE, is a tunneling protocol used to encapsulate a variety of network protocols within IP tunnels. Traditional GRE requires a unique tunnel for each endpoint, which can become complex and resource intensive with multiple endpoints. Since GRE adds its own header and footer to each packet, the payload size can be increased and the proportion of overhead relative to the payload is reduced. Jumbo frames can result in a more efficient use of network bandwidth and performance. Jumbo frames allow for the transmission of larger packets than the standard maximum transmission unit, or MTU size, of 1500 bytes used in Ethernet networks. Multi-point Generic Routing Encapsulation, or MGRE, is a tunneling protocol developed by Cisco that allows multiple remote devices to be connected to a single virtual private network, or VPN. It's a single tunnel interface that can dynamically establish and terminate connections with multiple remote peers without the need to predefine each endpoint. It supports multiple destinations, enabling multi-point or one-to-many communications. This is especially useful in VPNs and dynamic scalable network topologies like Dynamic Multipoint Virtual Private Networks, or DMVPN. Hub and spoke and full mesh topologies, where MGRE allows DMVPN to create dynamic on-demand tunnels between branch sites, enabling more efficient routing in hub to spoke or even full mesh network topologies. MGRE's multi-point functionalities make it ideal for scaling VPNs without creating individual tunnels for each endpoint, which is essentially beneficial in large networks with many branch locations. Enterprise branch connectivity. Branch-to-branch communications for companies with numerous branch locations. MGRE enables branches to connect to each other directly, often called spoke-to-spoke communications, without routing all traffic through a central hub. This reduces latency, improving efficiency, and optimizes bandwidth usage. Cloud integration. Many enterprises use DMVPN with MGRE to connect branch office securely to cloud services, allowing for flexible dynamic connections to cloud providers. Disaster recovery and backup links. Failover and redundancy, where MGRE is commonly used to create failover links in WAN designs, enabling quick rerouting to traffic if the primary path fails, which is essentially useful for organizations that require continuous availability. While SD-WAN has gained popularity, especially for WANs that prioritize direct internet access and cloud integration, MGRE with DMVPN remains a popular choice in organizations that require private, reliable, and scalable VPNs without fully moving to SD-WAN. Some organizations even use SD-WAN and MGRE-based DMVPN in combination, depending on the requirements of different sites. It remains highly relevant in networks where secure, multi-point VPN connection is required and works well alongside newer technologies like SD-WAN in many cases. Question: which of the following will reduce routing table lookups by performing packet forwarding decisions independently of the network layer header? Answer: MPLS. Question: a GR tunnel has been configured between two remote sites. Which of the following features, when configured, ensures the GRE overhead does not affect payload? Answer: jumbo frames. Question: which of the following use cases would justify the deployment of an MGRE hub and spoke topology? Answer: a network expansion caused by an increase in number of branch locations to the headquarters. Question. A network administrator is designing a new data center in a different region that will need to communicate to the old data center with a secure connection. Which of the following access methods will provide the best security for this new data center? Answer: site-to-site VPN. Question. Which of the following is the most secure way to provide site-to-site connectivity? Answer: IPsec. For more information, visit these sites. In summary, enterprise organizations have access to a variety of broadband technologies designed to meet diverse needs in terms of speed, reliability, scalability, and cost. Traditional broadband technology includes cable broadband and digital subscriber line, or DSL. Both are used to small to medium sized enterprises with moderate bandwidth needs and availability in rural areas. Ethernet over fiber is delivered over fiber optics infrastructure with speeds of 10 megabits per second to 100 gigabits per second. Enterprise wireless technologies include fixed wireless broadband, satellite broadband, and cellular broadband. A private lease line is a dedicated communication channel that connects two or more locations for private use and is a direct point-to-point data connection provided by a telecommunications carrier. Digital Signal Zero, or DS0, is a fundamental building block of digital telecommunications systems and is the private lease lines such as T1 and T3, and it represents a single digital channel that transmits data at the rate of 64 kilobytes per second and supports a single full uncompressed duplex voice channel. Dedicated Internet Access, or DIA, refers to the type of Internet service where a business is provided with a dedicated, uncontested connection to the Internet. Multiprotocol Label Switching, or MPLS, is a high-performance method for directing data across networks, commonly used in service providers and enterprise networks to enhance the efficiency, speed, and reliability of data transmission. Virtual private networks, or VPNs, are commonly used to connect enterprise networks across multiple locations securely and efficiently. Generic Routing Encapsulation, or GRE, is a tunneling protocol used to encapsulate a variety of network protocols within IP tunnels. Thank you for watching this video. The next video will be Advanced Networking Concepts, Part 2, Network Virtualization. If you like this video, click the like button, and if you haven't already, subscribe to the Pat Hedger Back channel. Thank you.